Okay, so generally there are two types of administrators for Teradata. The first type of administrators are called as the system administrators, where they closely work on the system level configurations, upgrades, the patch installations, all such system level things. And the role of these DBAs is more hardware oriented, and the number of positions in any organizations are relatively less than the application DBAs. Okay, the other type of DBA activity is called as application DBAs, where they closely work with the developers, architects, get involved in the modeling reviews, code reviews, and in the implementation or the physical implementation of the databases. All these are the activities of the application DBAs, where they more oriented on the software level of the Teradata. Okay, so here in our administrator part, we more deal with the application level. Okay, so when we are in application DBA, where we are responsible for managing one application, okay, what all activities we generally do. Okay. So some of the functions of the Teradata DBA include the user and database management, where we'll create users as per the request, where we may drop the users or may change the request. And then we have space allocations. That means we may allocate space, or we may remove the space, and we may monitor the usage of the space and add the space or delete the space proactively. Okay, so there are some alarms where we can set so that you will get an usage emails that this particular database is already filled, so you have to add spaces. So all those active space management activities also are done by the DBAs. Then access of the objects. So what all objects can be accessed by which users? What all databases should be accessed by the other users? What all tables, what are views, macros, each object level or database level, a user level, all the accesses will be maintained. If a user requests, I need access on so and so database or so and so table, we will analyze, is he belong to that application, and is application owner knows about this. All these things we will analyze, and then you will finally provide him the accesses as per the documentation. And then access controllers and security. That means how the users can be logging into the system, and what all objects they have access. Okay, so it is from the object level we will see, okay, all these objects by whom these will be accessed. But here from the user perspective, okay, for this user what all objects are accessible, and while he logging in, what are the credentials, what are the default roles, profiles, so that defaultly he can access few objects, or defaultly will get some accesses. All those activities will manage at access controlling and security. And then general system maintenance, the active system maintenance, you can say. Get to see what all current users logged in, what all current sessions active, what are the current SQLs being executed, is there any blocking between the users or between the SQLs. If there is a blocking, it is of which object, what are the logs performed, okay, is it an archival utility is running or the load utility is running, so that you can kill those processes and can make the deadlock resolved. Or if you observe, if a particular user is executing a non-window queries, that means non-business hour queries, then we will find out, okay, do we need to increase his priority as per a ad hoc request? Okay, how we can increase the priority for this particular session or for that particular SQL only? All those maintenance activities are performed in the system maintenance. And then system performance and resource monitoring. So it is to monitor the performance of the SQLs. Okay, so there are some processes where we call them as database query logging and access logging. Okay, with the help of the database query logging, we'll see what are resources this particular query is occupying. Okay, when this is the time, if it is executed, what are the resources, and if it is in other timings, what are the resources. When I say resources, it could be space, spool space, it could be CPU cycles, it could be IO cycles. Okay, so all these are called as resources of Teradata. So we have to ensure each and every request should be executed with a minimal number of resources. Okay, we will have the performance monitoring as an activity. Okay, if we have 10 DBAs in the team, generally they would share 2 hours each to monitor the performance. Okay, so today 3 or 4 DBAs would monitor the system for each 2 hours, and then again tomorrow 2 hours each DBA. Like that, the system active performance monitoring is shared among all the DBAs so that they will involve in other activities, and the performance is also monitored by the active DBAs. And then the archival and restore recovery requests. It is very general that DBAs has to take care of the archival process of the databases, and whenever the users wanted to restore to a previous versions of the database objects, okay, you will get a request again to restore the object how they were so and so date. So we have to restore them, and you may have to recover them. So all these activities are also part of the database administrations. Okay, database management, user management, space management, access control and access management, system maintenance and performance monitoring, and the archivals and restores. So these are the broad category of the database administrator activities. To understand all these activities, we have to understand the hierarchies of the databases. When I say hierarchies, the parent-child relationships, how they are aligned with, how the spaces are shared, how the resources are shared among the hierarchy, how the accesses are gained as per the hierarchy. All these things we have to understand. So to understand this, we'll go through the administrative environment, the administrative user environment. So here in the slide you see the DBC is the first user. So when your organization purchase Teradata, so Teradata Corporation would come and configure the RDBMS. So when they configure all with hardwares and all softwares, everything is patented for Teradata. So they will provide their own hardware, their own software, and they will install the RDBMS. And when everything is ready for the application DBS to use, the first database or first user available is the DBC, database catalog. Okay, this is the super user of the whole Teradata server. Okay, so as DBC is the user, there will be a password associated with it. So whoever knows this password, he is called as a super DBA. Okay, so no other DBAs would know this password. Very few members, maybe 1 or 2 people in the organizations would know this DBC password, because it is very dangerous as it has all the accesses for everything. So only the super DBA would know the DBC password. There are some occasions where the super DBAs forgot the password, and then again they approach Teradata to unlock this DBC user itself. Then again Teradata charge more to unlock the DBC users. So it is very precious user ID, where it will be known to very few people as it has all the accesses. Yeah, and it is not revealed to any other application DBS or system DBS even. Okay, so this is the first user which comes along with the Teradata configuration. Okay. And along with this, there are some other users and databases coming with. The whole space, whatever you purchased, first it will be allocated to the DBs. If you purchase some 500 terabytes of Teradata, all 500 terabytes is allocated to the DBs first. That is the permanent space. The whole permanent space which you purchased from Teradata is added to the DBC user first, and then there are some other databases which would come along with the DBC. Out of them, some of the users or databases would occupy some space. The first one is sys calendar, where the sys calendar is a database which pulls the space from the DBC. How much space? It is 15 MB. Look at the blue space. You can see. Okay, the whole space is 15 MB, and out of this 15 MB, some space is already occupied, the current space. Right? This is the maximum space allocated to the sys calendar. How much is that? 15 MB. And out of this, some system calendar tables occupy the current space. All system calendar activities, all the tables related to the calculation of dates, everything are occupied here. And that's where it can calculate what is the date after 3 months, 4 months. How it able to calculate? Because all system calendar applications, tables, macros, views, everything are existing in system calendar, sys calendar. Okay. And then there is one more database called sysadmin, where it would have some logs while execution of the system of applications. It will maintain its own logs. Okay. And one more major activity of sysadmin is when we are executing the fast load utility, the restart logs automatically maintained in the sysadmin database. Okay. For all other utilities like multi-load and fast export, you see the log tables are mentioned by the user in the scripts, but for fast load you don't mention the log files, but it is internally maintained by the sysadmin. How many fast loads are running, and for each fast load it will internally maintain a restart logs. Okay, so once you, if you already know the utilities, you might have understand. Otherwise, in the development we go through those utilities part. So there you can observe the difference in the scripting of the fast load and the multi-load fast exports, where we don't mention the log files in the fast load scripts. Okay, so all those restart logs are internally maintained in the system admin, sysadmin. Okay, along with that, the internal maintenance of logs are also created in the system. And there is one more database with system FE. Okay, it is called as the system field engineer. Okay. The responsibility of the system FE is to maintain the failure logs. That means if something happened and the system is crashed, so before crashing it will maintain some logs, the failure logs. Okay. So when you call the Teradata corporation for any issue, first they will come and they will log into the system FE user. So this is a user actually. So the system FE, the default password is service. These field engineers would come and they will log in with system FE user ID with the default password called service. If the organization can change, they can change, but the default password for system FE is always the service. So they will come up and they will log in with this user and they will see the dumps created in the FE tables to understand what is the failure and why it is failed, and to identify the root cause of the failures. To identify the failure causes, they use the system field engineer, the user. And then we have the crash dumps, which is used by the PDE. Given PDE, what is PDE? PDE is the parallel database extension which is installed on the operating system to enable operating system to understand the database parallel activities. Right? So these crash dumps are being used by the PDE during the communication of the internal architectural components. Okay. So it is required almost 3 times of the PDE size. So generally, if for one day, if it is using some 300 MB, then you have to allocate 1 GB of space for crash dumps, so that it is always 3 times of the usage of PDE per day. So this is the estimation how they do, how much crash dumps we have to allocate from the DBC. It is not our responsibility, it is the Teradata Corporation. So they will estimate what is the configuration, and for this configuration for PDE per day how much space is required, and as per the estimation they will give a 3 times of the space for the crash dumps. Okay, so it has a regular maintenance of dropping the old dumps. Okay, so these are some default users which occupy some space, and if you observe these are also default users and databases coming along with the DBC, but they don't have any space allocated. Only these 4 would have some space allocated with this. So let's come to this, what they do. All, default, public, and TDP user. So these 3 and this TDP user are basically for reserving the keywords. They are not currently being used much. They are reserved names where the users cannot use these names for the object names or database names. It is for future purpose maybe. So they have reserved it and they don't have any space allocated. And coming to SQLJ, it is introduced from Teradata 12 onwards. Okay, the responsibility of SQLJ is to have the JDBC related functions. And so JDBC, we know ODBC, right? Open Database Activity, where you can connect the databases through the protocol, the ODBC. In the similar way, we have JDBC. So all the JDBC connectivities, the functions which are related to the JDBC connectivity are maintained in the SQLJ. And then we have syslib. It is to register the user-defined functions. Okay, we know the normal function, we know date functions, we know string functions, all functions we know, the case functions, everything. A part of these existing functions, the system functions, if you want to create your own function and register in the syslib so that all other users can use this function as if they are a normal function. Okay. In your organization, in your application, if you feel a particular function is very much required and you have written some code in C++, Java, the COBOL, okay, you have compiled that program and you can register that compiled object in the syslib so that you can use that function as if it is a normal function. How the string functions or date functions are working currently in the system. So syslib is to register the user-defined functions. And it is sysudtlib. This is to register user-defined data types. Okay. We have so many data types in Teradata. Right? We have integer, the number types, the character types, the raw bytes, the graphics, everything. But if you feel in your application you should have any new data types which are not existing in Teradata, then you can create your own data types in any of the third-party languages, and you can register that compiled data types in this UDT-lib, user-defined data types, so that the data type can also be used. So for example, I have integer, I have small integer, I have big int. Okay, I want to create a huge integer. Okay, the space which is occupied by the big int is also not enough for me, and I wanted to create one more data type. Like I want to create a huge int as a data type. Okay, if you are familiar with the languages, you can write down the programs how they define the actual data types, and you can compile it and can register the data type here in this is UDT lib, so that it also can be used as a normal data type in the RDBMS. Okay. This is the system spatials. Okay. It is a special purpose database added from Teradata 13 onwards for maintenance of the spaces, the monitoring of space logs. Okay. So these are the default users and databases coming up along with the DBC. And once they once they configure all this DBC with the default databases and users, then they will ask the application DBAs to start creation of their applications. So in these applications, okay, the DBA, the master DBA, would create a database called sysdba. Generally, this is the way how they follow. The name is a user-defined name. Any name you can give, but generally they follow sysdba as the first and foremost application DBA, where it will pull the whole remaining space from DBC. So let's suppose 500 TB space we have purchased from Teradata, and all these databases are using some 3 GB or 4 GB. The rest of 497 GB is aligned to the sysdba. So from here onwards, you start pulling space for each and every individual application. So sysdba is created after configuring all this DBC and the default databases and users, and which has the all remaining space allocated to it. So the recommendation is create a database administrator which owns most of the perm space. So whatever space is remained after creation of this default databases and users, all the space is allocated to the sysdba. So this is the master DBA of all the applications. So whatever application you want to create, you have to pull space from the sysdba. Any questions, anyone up to here? Okay, good. So let's move ahead. So sysdba, it is the first and foremost database which is created after the actual configuration of DBC. And then here you can see the child and parent relationships, okay, which is called as a parent, which is called as a owner, which is called as a child. So this terminology is used in the rest of the concepts. So here DBC is the super DBA user. So from the DBC we have created a sysdba which pull all the space, the maximum space from DBC after allocation of the default database. Okay, here is a question. What is a sysspatials? Sysspatials is for the space related maintenance. Okay, so it is introduced in Teradata 13 onwards. It is majorly for maintaining the space. Okay. I will give you some more oversight about sysspatials. Please remind me tomorrow. So it is basically for space related, and what are the other activities I will explain. If you are interested in knowing this is spacious, which is very new database added, I will give you more oversight about this. So for now, you know the DBC and you know the sysdba, which is pulling the maximum space from DBC, and then from here onwards each and every application would start creation of their own applications. So from sysdba I want to create an HR application database. So I have created a HR database, and I want to create an accounting application DBA database. So I have created accounting. Okay. So from human resource I would like to create the personal HRs and the benefits of the human resources as a different application. So both are the part of human resource, but they are different in terms. And within the personal you may create some other databases. Okay. So if you consider any of the database in the hierarchy, all the objects which are directly above this current object are called as the parent or a owner. Okay, if you consider human resource, what all are the parents of the human resource? Whatever objects directly above the current object, that is DBC and the sysdba. These are the parents or owners of the human resource. And whatever objects directly below the hierarchy are called as childs. For human resource, the personal, benefit, PR01, everything is called as a child. And if you observe, a user can have a database as a child, and a database can have a user as a child. It can happen in any way. Users may own databases, databases may own users. But what is the difference? Only the user has a password aligned with it, where you can establish a session by logging in with the user ID and password. That is the only difference. But the rest of the properties of database, where it can hold the objects, where it can hold the space, everything is common. And in the hierarchy, whatever objects just above it are called as parents or owners. Sometimes you may call it as parent, or sometimes you may call it as owner. And whatever objects directly below the hierarchy are called as the children or child. And which is immediately above in the hierarchy is called as the immediate owner. Okay, from where it is pulling the space. Okay, so this human resource is directly pulled space from the sysdba. Right? While creation of this human resource, we have to specify from which user we have to pull the space. So when we are pulling space from the sysdba, sysdba would become the immediate parent or immediate owner. Okay, based on the space from where you are pulling, it is called as a immediate owner or immediate parent. And sysdba become immediate parent here, and human resource will become a immediate child of sysdba. Okay, to represent from where it has pulled the space and to which it has immediately given the space, we use the immediate word before the parent or the children, so that we can understand, okay, so this is the immediate parent and this is the immediate children. And accounts is also an immediate children of the sysdba, and for accounts, sysdba is the immediate parent. Okay, for PR02, who is the immediate parent? The personal, from where it has pulled the space. Okay, so this is the terminology of owner, parent. Both are same. You may call immediate owner and immediate parent to represent the objects which are pulling space from the objects And similarly, the children which are below in the hierarchy, all are called as children. And if you want to represent the immediate children, where it has contributed space for the existence of the object, it is called as the immediate children. So here in this example, you can see who can do what activities. That means we know DBC, we know sysdba. Sysdba can generally create objects within its chains, right? So human resource is created by sysdba, and within human resource we have sorry, the personal and benefits. Okay, so now sysdba has granted user access on the human resource user to accounting. Just please understand the statement. So granting user access on the human resource to the accounting. Generally, who will create the objects within the human resource? By pulling the space from human resource, the human resource will create the objects, the personal and benefits, right? By pulling space from human resource. But here the accounting is creating the objects within the human resource by pulling space of human resource. How it is possible? Because the parent of the accounting or the parent of the human resource has to grant the access to the peer. So these are peers, right? These are peers. So in order to have the access on other objects, the parent of both the objects has to grant access initially. So as a sysdba, what the action is done? Grant user on the human resource to the accounting. It means accounting has a user creation access on human resource database. So accounting, what he did, he has created a user payroll from the human resources as a password, whatever spaces you want to allocate, the temp space, full space, everything can provide here as details. So basically what he did, accounting, he has created a user called payroll under human resource space. See this. This payroll is being created by accounting, but from the space of human resource. So who is the owner of this payroll? Who created it? Accounting. So accounting become creator. So you can see here, the creator is the user who submitted the create statement. So who created this object by submitting a create user statement? That is accounting. So he is called as a user. Who? Creator. This user is called as creator of the payroll. And who is the immediate owner of this object? Who has contributed space for the existence of this object? That means human resource. So human resource is the owner because it has pulled space from the human resource, but it is created by the accounting. So creator is accounting, the immediate owner is human resource. So see these points. The creator is the user who submits the create statement, and every object has one and only one creator because only one person can create that object. A user may create database or other users from someone else's space provided if he has access. That's what happened here. So by default, accounting cannot create any objects under human resource, right? Because it won't have any rights in using human resource space. But how the account able to create a user within the human resource space? Because the sysdb has granted the user access to accounting on the human resource database. So accounting started creating objects within the human resource, so it could be a creator of the objects in human resource. Okay, so here we learn a new terminology called creator. Okay, owners, parents, children's, creators. Okay, there is a question here. Under what circumstance do we create a user like this? Sometimes this is a user and this is the database. Okay, we want a integrity between two applications by having some common dimensions. Okay, so we'll maintain a single dimension across different applications. So that way you may use one user as a creator, where you will create and you will granted access so that you can access objects of other databases and you can create it. Okay, so there are several circumstances where you can use the other space to create the objects. Okay, you know conformed dimensions, right? So in the conformed dimensions where different applications are using common dimensions, okay, you can use the scenario of creation of the objects commonly for different applications. So it could be in accounting or it could be in human resource, but here I have decided as an account I will create in human resource so that I can access these objects commonly for both the applications. In such a way you can create, but by default you cannot do that because it is a peer and by default it won't have any access. The parent has to grant access. Okay. And here you see the command called give. What is a give here? So in the earlier diagram you have seen accounting has created object from human resource. Now after some time I decided this payroll should be completely given to the accounting by separating it from human resources. Now what I can do, as a parent of these two databases, that means the parent of these two databases is SysDBA. Right? So as a SysDBA I have to log in and I have to give the payroll to accounting. Simple statement. So the payroll which is created under human resource is completely given to the accounting. See the association here. Now it is completely moved to accounting along with its childs. Whatever children, whatever space, whatever accesses, everything is moved from the human resource to accounting. Okay. But what happens when you given all the resources to accounting, this human resource does not lose its accesses on the payroll. So your intention is to separate this payroll from human resource to accounting, and you have separated it with the give command. But the give command characteristic is it will add the new accesses, but it won't drop the existing accesses of the old objects. So there may be some accesses still existing on the human resource, on the payroll to the human resource. So we have to be very much careful when you are executing the give command. You have to understand, okay, whether this give is for space purpose, it's fine. The space is moved. But if it is for the access purpose, you should not use give. Okay, so if you want to get this human resource lose all the access, then better way is you have to drop the database, okay, and create it again. So that when you drop, the rights will be dropped, and then when you create, the new rights will be created. But if it is only space related thing, what you want to move, then use this give payroll to accounting. What it does, the give statement is valid to only transfer databases and users. The whole hierarchy will be given. And to give the object, you must have the drop database privilege on the object to transfer and create database privilege on the receiving object. It means you cannot do this give command by logging in as a human resource or by logging in as an accounting. Why? Because account may not have drop access on the human resource. Here it has only the create user access but not the drop user access. Okay, so here when we are moving, we have to drop this database from the human resource internal. So accounting cannot do. Human resource cannot create any objects under accounting. Okay? By default it won't have access. So who can do this activity? The parent of these two objects, that is SysDB, where it has the drop user access on the human resource and where it has the create user access on accounting. So this particular user can only do the give command because internally it has to drop the user from the human resource and it has to create the user under accounting. And as I mentioned, this give command is generally used to move spaces. For example, I observed in the human resource there is a lot of space available, currently is not used, and in accounting it is running out of space. Then if I want to move some space from human resource to accounting, then what I generally do, I will create a dummy database here by pulling some space, and then I will give that dummy database to accounting so that the space is moved to accounting. That is the scenario where I generally use the give command. But in terms of access, we generally don't give because the access are not lost by the already existing one. So it is a dangerous command sometimes. If it is only about the space, we use the give, but we don't generally use give in terms of accesses. And we have to understand when we have to apply this give command, we have to have a drop database access on the objects to be transferred and the create database access on the receiving objects. Then only we can do this give operation. And here it is to delete some objects from the hierarchies. SysDBA, we have a human resource. So within the human resource we have personal, and in the personal we have all these objects. Now I want to delete the complete user. How I can do that? I cannot drop the user directly. First I have to delete the user so that all the objects will be deleted. So the first step when I want to drop this, the whole object personal, is the delete user personal, where it will delete all the objects. And now when this database is not having any members, then you can write the drop user so that it will drop the entire personal and the space is added to the immediate parent. So now the space, the whole space which was occupied by personal is added to the immediate parent human resource, and the whole object is dropped. And you cannot do a drop directly. First you have to do delete so that all the objects are deleted, and then only you can do a drop. Okay, it is just a two-way activity of dropping to ensure that you are intentionally dropping it. If this is allowed, if you give it accidentally, that's it. To ensure you have a smooth drop intentionally, they have a two steps of deletion. First you have to intentionally give the delete user so that the objects will be deleted first, and then the drop user, then only the space is added to the immediate parent and the object is deleted. Yes, so these are some basics of the hierarchy and the operations what you can do in the hierarchy. And tomorrow we'll start with the data dictionary. Yeah, I will open the Teradata database administrator and we'll see some basic activities in the tool, and we'll start with the data dictionary. Yeah, what are the important things what we should learn in the data dictionary part and how we can use the data dictionary tables for the daily routines. Any questions, anyone here? Okay, good. Then we have, yeah, go ahead please.
Manohar, this DBA is nothing but it's a Teradata DBA, is there?
Yeah, this is all about Teradata DBA activities and the hierarchies.
Manohar, can you give some more overview of the give command?
Okay. So give command is basically to give the accesses, the ownership and the space to other database. Okay, so give the database or user which has to be moved out from the existing parent and to the object to which it has to be moved. Okay, and I'm getting noise. If you can mute yourself, great. Yes. Yeah. So when we are using give, we have to ensure 2 points here. This give command can be executed by the parent of the databases from where you want to move or to which you want to move. So here I want to move from human resource to accounting. So I cannot do this give operation either as a human resource user or an accounting user. But who can do this? The user who has a drop user permission on this source user and who has create user access on this destination user. So who has this common characteristic? The parent of both the databases and sysdba. So you have to log in as sysdba with the sysdba password, and then only you can perform the give operation from human resource to accounting. Otherwise you're not able to do this give operation. And when you do give operation, what happens? It completely moves the space, the ownership, everything to the destination user. But it won't delete the existing accesses by this user. Okay, so if your intention is to move only the space, it is fine. But if your intention is to move the access rights to the new database, but the old database should not have the accesses, then you should not use the give command. Then better way is you drop the user here and create the user there. Okay, so in terms of space,
in this case, since accounting was the one that in this case, since accounting was the creator of payroll, can human resources drop it?
Human resource can drop payroll.
But the owner, sorry, the creator was accounting, right?
Yeah, the creator is accounting, but the owner, the immediate owner is human resource. So by default, the owners would also attain some accesses on their immediate children. Okay. So the access part you will get. What are the default accesses? What are the automatic access? What are the derived access? Everything will be get to know in the access part.
So the owner and creator have equivalent access rights.
Not equivalent. There is a slight difference in the accesses. What a creator would get and what a owner would get. I will show you that. So this is all to give the terminology basically. Okay. So who is the user? Who is the creator? Who is the parent? Who is the owner? Who is the child? So once you are familiar with, then we will gradually move towards what a user would get access, what a creator would get access. Everything will see.
It looks like database and users is somewhat synonymously used here.
Yes.
Right? So is a create user and create database command the same, or are there two different commands for each?
It is different in terms of using the word, whether you are using the user here or a database here. That's it.
But the other things like giving the spool space and the
Yeah.
temp space, that all remains the same?
Everything remains same, but the only one extra property for user is the password.
Right. Yeah.
Okay. But if you use a database keyword here, you cannot use the password, but you can use all the remaining spaces.
Can a user create more users?
More users. What's that?
I mean, like in a database, you can create a bunch of users, but if you created a user, then that's it. You cannot have any further child relationship
No,
with
no.
that user.
So that is the first statement here. You can see users may own databases and databases may own users. So within the user also you can have your own tables, your own views, your own macros, your own stored procedures and functions. So user can also hold all the objects. That's why we are saying the only difference is the password. The rest all properties of database exist in user also.
But users will not own users.
They can. Users can own users. Users can own databases. Similarly, database can own a database. Database can own a user. Every permutation
So
is
you're
possible.
saying the sysdba is both a database and user.
Pardon?
Sysdba here in this picture is both a database and a user. It's like
No.
a super database and super user.
It is generally a user. Okay, so if it is assigned with a password during the creation, it is a user only. And in this user, we are creating different databases. Okay, if you want to create these as a databases, you can create, or a user. If you want to create a user, you can create it. Anything is possible. And how you will get to know which is a user and which is a database? In the administrator. You can see by seeing the icons or by seeing the definition of the object, you can get to know whether it is. Yeah. Can you people mute yourself, please,
That's not
if
me.
you are not asking questions? If you are not asking questions, please be on mute so that you will get clear line. Okay. Yeah. So it's fine now. Any further questions? Fine then. Okay, so we'll go to the regular class of development in 5 more minutes. So please take a break and please gather again for the development session. Okay, who are opted for development, please be online, and who are for only DBA can drop now, or you can stay on the line for the development session, which we start in 4 more minutes. Thank you.